Onufer, and I teamed up with Jaydeep Marfatia to complete the Capstone project for the recent GenAI intensive course delivered by Kaggle and Google. The goal of the project is to apply what Jaydeep and I had learned in the intensive GenAI course by leveraging some of Google's LLM models and various GenAI capabilities. During this project, we will demonstrate capabilities from grounding with a homegrown database, functional calls, APIs to an external system, and structured output, and building an agent with tools. So in this particular project, Jaydeep and I wanted to take on, our use case is really taking on one of the biggest hassles of flying, and that's dealing with canceled or delayed flights due to weather conditions. Have you ever had a flight delayed or canceled due to weather conditions at either end of your flight? Did you miss a meeting or event or dinner because of weather delays? If you fly more than a couple times a year, you probably had this happen to you. So in this notebook, which I'm showing here, we will leverage LLM models, real-time APIs, and agents, and a grounding database to show how an air traveler can interact with a chatbot, AI chatbot, about the weather conditions at his or her departure and destination locations, and hear back from the chatbot the risk of his or her flight being delayed or canceled, and categorizing those risks, as you'll see in a color code. So let's jump into our notebook and demonstrate our GenAI capabilities. So the first part, obviously, is just loading the Kaggle base environment and LangChain using Python here. So one of the things that we have here, obviously, is a Google API key, which in order to get the LM models. We also loaded our own database here. So you see this file, top100airports.csv. We created our homegrown database, which listed the top 100 airports in the US, ranked by passengers served annually. And in the columns included, passengers served annually, airport name, what its IATA three-letter code is. So for like San Francisco is SFO, or Chicago is OR, and then the airport address, and then we geolocated that. So basically the latitude and longitude. And you'll see later on why the latitude longitude was important. So this is important because we're going to be calling this database in order to run this tool set. And then separately, we went out and got a separate API from OpenWeather. It's a free API. We're using the free API. We didn't cover this in the actual GenAI course, but making us familiar with the Google APIs, we decided we wanted to come up with an API that had something that was, the most recent data, obviously real-time data. And what is more than that than weather. So to run this, you do need to go to OpenWeather Map and access the API key. Although there's an option to get a free one if you sign up for it. And then specifically from that weather key, we need to sort of pass the latitude longitude, and that will pull the weather for that very specific location. And imperial is just, Fahrenheit instead of Celsius, things like that. So you can see here what we did just to test it out with the code is grab the latitude longitude from the database of the Atlanta airport, 33 degrees north, 84 degrees west. And then, that pulls down here all different weather parameters from 81 degrees Fahrenheit to, the pressure, humidity, visibility, wind speed at 92 degrees, things like that. So next thing that we did here was showed some structure output from the weather API. When the call gets returned to our model, our chatbot, it requires for us to look for very specific items in order to come up with a risk assessment. So basically, we've come up with this red, orange, yellow, and green risk assessment. Red means really good chance you're going to need to, your flight's going to be delayed. Orange, moderate chance that your flight's going to be changed or canceled. Yellow, small chance. And then green is basically, no chance that your flight's going to be canceled because of weather. Obviously, this doesn't apply to mechanical issues or things like that, but what tends to be the biggest variable in travel tends to be weather. So you can see the conditions for things like red, tornado, hurricane, tropical storm; orange, thunderstorm, freezing rain, heavy snow; yellow, rain, snow, sleet. So if it's any of those words appear in the conditions, then that will come back with that color ranking. We also did with this with temperature, so above 100 is red, and orange and yellow, so on, and then also wind speed. So above high wind speeds, high above 58 red, by above 25 yellow, and then if none of these conditions are met, it comes back as green. So we will get more into that. So this is basically, hey, are the basic tools working? Can we actually map that latitude, longitude, make the call, and then make the risk assessment? So here we did for ORD, which translates to the Chicago airport. You come back with the coordinates. Rosemont is the town in which the Chicago airport is located, the temperature, and you can see that they may have some rain, they have moderate rain, and that's why the risk assessment is yellow. So the next important thing was for us to basically demonstrate building a chatbot agent and using one-shot prompting to get the output we wanted. So what you'll see here is the system prompt, your travel helper for air travel. We, from an airport travel information, we want the weather from the origination and destination airports, and so create the risk assessment and summarize the weather. And this one we also asked for travel tips around clothing. So, and then here's an example that we did from San Francisco to Chicago. So we go down to the chatbot. Basically the chatbot is going to start talking to the human. They're going to say, okay, so the chatbot here is saying, okay, great. You're traveling from San Francisco. I'm sorry, this is a human message. I'm traveling from San Francisco to Chicago. That's SFO to ORD. And then, this is the type of information that we're asking it to put out, that it would put out in that particular, for the user message here. But we also asked for the chatbot to introduce itself to the user, which we'll get to when we show the full chatbot. You see here, these are the key nodes on the chatbot, between the chatbot itself, the human node, which is what the human's going to enter, where they're going to, where they're traveling from to. The geo node, which is then calling the database in order to get the coordinates. The weather node, which is calling the weather API and pulling back the current conditions. And then the risk node, which is parsing those conditions and putting in a bucket of, red, orange, yellow, or green, and then reporting that back to the users. So I think here's a really good description of a diagram of this chatbot, with the chatbot, welcome to Travel Buddy. Tell me about your air travel, starting the interaction with the human then putting the to and the from, where they're going to, and then that calling back to the chatbot then calling the geo node to get the latitude, then going from there, making an API call to openweather map.org, then returning the current conditions for both cities there, and then creating a risk profile, and then reporting back to the human. So let's take some real life examples here. So let's say I would like to travel from SCE, Seattle, to BOS, Boston. And let's see what it tells us here. So you can see it going through, getting the temperature, scattered clouds, and then it comes down here with the summary. The weather in Seattle is characterized overcast clouds, 50 degrees Fahrenheit, wind at just over 11 miles an hour. The weather risk is green, meaning no chance of delays due to weather, and it's advisable to wear layers based on the temperature and wind. And then Boston, it's actually warmer, 62 degrees. Wind speed is 18 miles an hour with gusts up to 27. Weather risk is green. Given the temperature, wind is advisable to wear layers. So, again, example here of this working. And we could also try another, just say, without the airport codes, I would like to travel from San Francisco to New Jersey, and have it be a little vague and see what the chatbot comes back with. And here it says, what airport code in New Jersey would you like to travel to? And I would like to go to Newark. see if it can get that one. And yes, so the airport code in Newark is actually EWR. But we get the weather in San Francisco, 61 degrees, wind speed of 8, weather risk is green, clothing recommendations, Newark, 66, wind speed of 23, and advisable to wear layers. So again, here we've demonstrated this particular capability through this chatbot here. It's interesting for us. We believe these not chatbots itself, but agents' ability to complete a task for a human are expected to be a huge growth in the software market and what companies are doing and changing the way that we're doing business. The global consulting company McKinsey has suggested that 50% of white collar work is going to be automated mostly through AI agents by 2030. So, really interesting things to be able to demonstrate through Kaggle and Google. And this is just a small example of what we tried to do here. Obviously, there's a lot of other things that we could have done here with real-time flight APIs and actually pulling up your flight and maybe trying to get it to look into your calendar and send you an email if there was a flight coming up and whether to change your flight. But for the sake of time, we didn't go through that. But I think you can imagine here that the capability that with the right data access and creating the right tools that these GenAI agents are going to be able to do a lot of things that required people to sort of type in information into UI right now that you're not going to have to do. Thank you, and we look forward to any comments that you might have on this Capstone project and this notebook demonstration.